Today's problem, counting elements in two arrays, difficulty medium. You are given two unsorted arrays, A and B. Both arrays may contain duplicate elements. For each element in A, your task is to count how many elements in B are less than or equal to that element. And there are a couple of examples here. Well, let's look at one. Array A, we have the first element is 4, and then there are 5 elements, 1, 4, 3, 0, 1, 1, that are less than or equal to 4. Next element is 8. Wait a minute. And there are, wait a minute, for A1, A2. Oh, okay, for 8 and 7, 6 of these elements are less than those elements. For 5, there are also 6 elements that are less than or equal to 5. For 1, there are 3 elements less than or equal to 1, 0, 1, 1. So that all goes into the output. And let's take a look. Size. The size of the arrays is between 1 and 10 to the 5th. 100,000. The numbers in the arrays are between 0 and 10,000. Expected complexities, n plus m, the combined lengths of the two arrays. Company tags, Amazon likes to ask this question. Topic tags. Well, I mean, the only thing that kind of jumps out here is binary search. I have a binary search solution here. It's not going to work. It's a little bit of a mix-up here in that, well, first of all, if the expected complexity is n plus m, which is linear, then you can't do a binary search, because a binary search is going to require a sort, and a sort is not linear. So you wouldn't get anything better than n log n or n plus m log n. I'm not sure, but anyway, you can't do a binary search in n plus m. And I guess we could look at why binary search doesn't work. I mean, here's the setup for that. It would be nice if it did work, and I mean, it didn't occur to me in advance why it wasn't going to work. But we're going to return an array list, so we define it. Sort array B. Can't quite see the whole method signature here. Right here, the array coming in is A and B. Sort array B, and then we'll go through array A, and we'll binary search array B for the number from array A. Now, the way the built-in binary search works in Java is if you get a match, then you get the index of the element that you matched. If you don't get a match, what you get is you get the index where the element that you were searching for would be inserted. That is then converted to negative, and you subtract 1. So, for example, this array here, 30, 40, 50, if you were doing a search for 35, you're not going to get a match, but 35 would get inserted at index 1. So what you're going to get back is -1 minus 1, in other words, -2. So that's what this if statement here is for. Is if we get something greater than or equal to 0, then that means we got a match, and we can just use that. I mean, the match would indicate how many elements are less than or equal to the element we were searching for. If we get a negative number, we can add 1 and then take the absolute value. Okay, so let's watch what happens when we try to do that. I'm just going to do the compile and run one example. I hope it's the same example. You can see why it doesn't work. Yeah, okay, so there's why it doesn't. There's why it doesn't work. This is what we were expected to get, 4, 5, 5, 6, 6, 6. What we actually got was 2, 4, 5, 5, 6, 6. The reason being, because you can have duplicate elements. So there's 3 1s here. Now we can sort this and get 0, 1, 1, 1, 2, 4. At that point we could binary search it, but it isn't going to work unless we write a custom binary search that, in the case of duplicate elements, always returns the what can we call it? The rightmost matching element. Okay. In this case, it didn't. It looks like it returned the first matching element. So writing a custom binary search to do that, well, it's probably easier to just do the n plus m solution. All right, so let's see if we can sketch this out first. We want to do it with a prefix sum. So here is the here's the array coming in, and we can do a well, let's see. First of all, we can do a count array. So let's just do this. 0, 1. This is the index for the array. 2, 3, and 4. That's actually all we need to show this. And every time we get a number coming in, we'll add to the count array. So we got a 0, we got a 1, we got a 2, we got another 1, we got another 1, and we got a 4. Is that right? 1, 2, 3, 4, 5, 6. 1, 4, 5, 6. Okay, yeah. All right. Now we can convert this to a prefix sum by keeping a running total as we go along here. So using, let me just do this, but using the same indices that we have up here, this is going to be 1. This we're going to add 3. Now we have 4. This we're going to add 1. Now we have 5. 3, there were no 3s, so it's still at 5. This one, the 4, is, we'll add 1, we have 6. Now because these numbers can go up to 100,000, we're going to need a big array here. But at this point, dot, 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 this is just, these are just going to be 6s forever because there was no number in the array greater than 4. So now if we go to, and that would include index, index 7, index 9 out here. So now if we went to array A, we could look up in the prefix array how many numbers are greater than or equal. So we have 1, and we look at 1, and the number would be 4. If we look at 2, the number would be 5. If we look at 3, the number would also be 5. If we look at 4, 7, and 9, those are going to be 6s. So we can use that solution, and let me put in an implementation of that. All right, so here's the new implementation. We still need the array list. We are going to have we got the count array. The length has to be 100,001 because we can have numbers from 0 to 100,000. We're going to fill up the count array based on the contents of array B. So we'll iterate through array B, and whatever number we see there, we increment that element in the count array. Now this converts the count array to a prefix array. Start at index 1 and add the previous element. So we get a running total. And finally, we iterate through array A. We use each number in array A as a lookup into the prefix array. Well, yeah, okay. See, now I'm kind of mad that maybe I should have made a separate, no, like a count array, and then calling it on a prefix array. Well, in any case, what we did was we converted the count array to a prefix array, and we should be able to do a lookup and return it. So let's submit that, see what happens. All right. So, what did we learn here? Well, we learned, a possible drawback of the built-in binary, built-in Java binary search if you are using it on an array with possible duplicate elements. If it's important, not just that you match the element, but that you match either the first instance of the element, the last instance of the element, something like that. You're gonna have to write it yourself, and then the value of a prefix array. So that's it. You can like the video, subscribe. You'll get problem of the day in your inbox every weekday. So we'll see you next time.